My name's Tom Nadeau. I'm Chief Cloud Architect at Spirent. I'm responsible for our products, cross-product architecture, things like that. I've got a brief slot today to talk about really the importance of testing. And a lot of that's been echoed in the presentations that came before me. And in fact, even yesterday when we were talking through some of the things in the technology space here, I was thinking, through the lens of testing and really past experience on working on projects like this in the past. And I have a bit of a few things to ask that we do in the project and things to point out for people to think about along those lines. And they're all related to testing, but they're also related to, for example, Kyle's talk yesterday about community and the importance of setting this up the right way. A few of us who are here, in fact, have past experience on projects that were maybe not set up quite perfectly. And so I'm also trying to learn from our experiences in the past here as well, which I'm sure a lot of you will appreciate. So one of the things that it seems to be typical of project formation, at least in the kind of this space that we're in here, is project focus on kind of like the discussion we were just having in the presentation before mine. How do we build a thing? What are we building? Let's get code rolling. Let's start building stuff. And that's fantastic and really a part of the recipe. But I want to make sure we're not forgetting that the things that go in the testing box, so to speak, those aren't done later. They need to happen now, so that this is set up really on the right foot. And things, for example, in the past, I'll go back to like an Open Daylight project that some of us worked on. We released code in that project for at least a year that had quality issues, frankly, and we addressed them when we could, but we put them aside in lieu of getting more features out and keeping the velocity and the trajectory of the project going. And really, as somebody who sold a large distribution of that project, that caused me lots of problems, as you could imagine, as well as my customers that were using that. And that's one of the lessons that I'm trying to bring to the party here today, is to and not just in theory, but also in practice. I'll talk about that later. But for example, developers write tests that go, with functional tests that go with the code they're checking in. And really, this is one thing I want to say out loud, is that they're typically part of the CI/CD process, and they all give people a real sense of false security. They're testing a certain kind of thing, a kind of functionality, but they're not testing the actual functionality that we want to output from the project. For example, like, this is not how you would build a product internally. You would just let the developers test the product and ship it. So what I'm proposing here is that, on day one, we have a testing group here that is responsible for thinking about stuff like this, setting up the CI/CD, and collaborating closely with developers to ensure that we're doing, maximum testing before we ship these things out. And that also leads to knock-on effects, again, like the previous presentation of mine about the OEM configurations and the repackaging types of configurations. If we start with a lower quality product at the beginning, at the core here, that's just going to make those other things lower quality down the road or downstream. Another thing that is a lesson I learned from my previous projects is not understanding the scaling limits. And this kind of gets into the telemetry of the project and things that people tend to focus on, which are like number of lines committed and code velocity and things like that. These are other very interesting metrics of the project, scaling, bug velocity, bug close velocity, things like that. And so one of the things that may not be obvious though is understanding the scaling limits of the project, and specifically on what types of hardware in this project. We're talking about different form factors of deployment. These are things that ultimately, customers like Mr. Bernier just said on the in the chat, he's a telco, he's interested in learning what this thing is before he gets it. And so that's a real important thing, because as you'd expect, scaling limits will change from release to release, for better or worse, right? And really, it's not a means to kind of judge the project or anything or its progress. It's really just it's data for people that are going to use that distribution at the time, that's cut from that release. So that's another thing. And along those lines, kind of handling security from the get-go is not handling CVTs that are reported. Another kind of thing that I've been remembering from a couple of previous projects, where it's not that they weren't purposely ignored, it's just that they were purposely reprioritized based on other things that were going on. And plus, handling some of these things is not the first choice of what engineers working on a lot of these projects want to do during the day, or even just understanding that they exist, letting downstream consumers understand that these are inside of this thing. Just everybody remember the latest CVTs that have been out for the last 3 months, Log4j and things like that. These are things that have been around for quite a while, and they're really not mysterious. It's just that they just weren't handled. So the proposal here is to create a security response team right away, who's responsible for fielding these things, creating our plan for how we're going to handle this stuff, and then again interacting with the developers in testing and development to make sure that they're addressed one way or the other. Testing on real hardware and in realistic use cases and scenarios. I understand these projects tend to kind of grow, and that's a feature. We're exploring what we can do with this thing as we go, but we should have some sort of target primary use cases for releases that we are targeting. Another learning again from the latter days of the Open Daylight project, where we realized that the totality of the kind of uses for the project, there were 50, 100 different side projects, but the core of the project was like a dozen components targeted at some very specific kind of use cases in the end. And so making sure that we not only test on those realistic use cases, but there are hardware components in this project, and doing everything virtual or simulated only goes so far. Is my lesson from previously when I was at Red Hat, when we started working on OVN. No one had apparently been running OVN on real hardware in NICs. It had been tested in one of the cloud environments, and literally the first time I ran that whole thing, it fell down. And it were things like weird timing things, weird driver things. These are the nuts and bolts of making sure these things are high quality. So again, back to the testing aspect and the testing team that works on this. It's important that this plan is sorted out at the beginning, but then also understanding that we do have hardware requirements for this project. The CI/CD should have some aspect of running on real hardware, at least for the key use cases we're after. And then discussions of integrations, back to the previous talk that was just on, but not just integrations downstream, I mean kind of laterally integration. So, this is a thing which is important to get a hold of at the beginning, even if there aren't really any dependencies or interactions, but just understanding that there probably will be somewhere, and having people that will handle that in the project anyway, that are tagged with handling that. and really, because this gets into things that I got into, where we had to, for example, synchronize release schedules, synchronize release schedules and dependencies. People were importing libraries from some of the other large projects or the entire project, and making sure those dependencies are handled in a good way, in a predictable way is important. A couple more challenges I just want folks to think about is, this gets into kind of the community aspect that Kyle was talking about. Support for non-devs. Non-developers in these projects have a lot to contribute and can have a very positive impact on the project. We already have operators here today. We have cloud operators, telco operators here. They want to participate. We need to give them avenues to participate, even if they can't produce code that works on the kind of the main project. Their needs for documentation, test plans, test scripts, use case outlines, things like that. So let's not lose sight of inputs from those folks as well. Sometimes they're like talking to your customers. They're sometimes your best source of data input on these projects. And a couple of other things that are maybe too simple and obvious, but I want to point them out because I've run through these myself. Uniform event logging and failure outputs. If we're going to have a crash dump or things like that, let's talk about that up front and figure out what that means. Channeling. I've been a network operator myself. One of the most annoying things is getting multiple formatted event logs that you can't easily parse. These are things like, we should define what our regular expression will look like for event log messages and use that, for example. And I can almost see the operators nodding their heads with a thing like that, because these are things that just add to the cost of using this. And it's back to operations, the importance of operations. And then I guess back to the telemetry section of things here too, which maybe not obvious, maybe not super interesting for core developers, but is something, as a user, in integrating an integrated testing function or diagnostic function on board the IPDU platform is interesting. A lot of the use cases for these are in remote servers and data centers and in other remote locations, edge locations potentially. Physical access to things is not necessarily guaranteed. So we need to make sure that that's handled in here as well, because that's something to, as I look at this, that's a very useful feature of this project. And then just to wrap up my section, I'm not sure if we're going to take Q&A or if a colleague from Keysight's going to go right away, but we'll just give you some things to think about at the end here. Think about testing and security now, before we have too many artifacts that create all kinds of things that we then need to go fix or address. Now's a great time to set that stuff up. We can have our CI/CD have stubs in it for testing functions that we can address, a little later or whatnot. But think about it now. And then, as I was talking about earlier, think about what our supported configurations are going to be, from the get-go for each release. I mean, this is part of thinking about release cadences and things like that. But what are we going to support? What kind of configuration? I've seen a lot of presentations with dozens of different types of configurations I could think of just looking at them, and that might not be realistic for the first release or the second release. But even as part of that, ensure, like I was saying earlier, that we have a true infrastructure for testing this, an infrastructure that reflects the truth of the configuration, so to speak, so that we are actually testing stuff before it goes out. and make sure that devs can access this thing. Some of the projects I've worked on, there are these labs as a service thing that are set up as an adjunct. And there's a couple of additional steps needed for devs to go use it or things like that. I mean, it's ideal if it's just integrated on day one. And then last couple of things, as I talked about, create a testing security team right away that then thinks about things like security, CVT vulnerabilities, and et cetera. And then also, the physical infrastructure and the CI/CD. That's it for me. I'll get off my testing soapbox now, but thank you for
Thank you,
listening.
Tom.